Hey everyone, my name is Andrew Hong. I work over at Dune. I am the headmaster there, which is a fancy way of, yeah, I saw the guys. It's a fancy way of saying that I lead our developer relations team, and my main job is education. For those who don't know, Dune is a data platform, probably one of the biggest community data platforms. We call our community data analyst wizards, so that's why I'm called headmaster. Anyways, I'm not here to explain Dune or my background. I'm here to give an introduction, a slight technical introduction to Solana. This is written in a way where, it's written with some Ethereum translation within it, because I expect probably half the people here are probably from Ethereum land. And our goal for today will just be to be able to get you guys to be able to read a block explorer. 20 minutes might be tight. We'll see how far I get. And I'm a research advisor here at Archetype. So if anyone has anything they want researched or public dashboards, we are here to help and talk about it. All right, so we don't have that many slides. We only got 9 slides, but they are pretty in-depth. There's going to be 6 steps here. We're going to break down the data explorer, or we're going to break down Explorer. We're going to break down instructions and computes, which is just the structure of a transaction. We're going to go into tokens and accounts, which is probably where I will lose most of you, but we'll try to keep you. And then we're going to go to programs and storage. And if you understand all of that, you'll be able to understand everything that goes on in Explorer. And then after that, there'll be some mapping of key projects for people who want to understand, like, is everything on Ethereum on Solana? Like, short answer, yes, there are projects. Like, if you take almost any Ethereum project, there is a Solana counterpart that is oftentimes, I think, better. And then last one, Solana data tools and resources. That's more for the people who are watching this recording to go and click around, because hopefully you're not using your phones right now. So breaking down the Explorer. This is what one transaction looks like on Solana. If anyone ever went to Solscan or Solana FM, which are the Etherscan equivalents, this is one transaction. It's like you could scroll for 15 seconds. One of the many times back in 2021 when I first tried using Solana, I was like, what the hell is going on here? I don't want to touch this. This looks extremely complicated. Just by show of hands, who here is able to read a Solana transaction on Explorer? I will quiz you. Yeah, that's what I thought. Okay. People always raise their hands. I'm like, if I say I'm going to pick on you, I know some of those hands are going down. Okay, cool. So this is a lot. This is the transaction for me opening up a perp position to go long on Sol on Jupiter. And so this is just all of the process to open a position of, I think I did $3 since I couldn't figure out how their program worked, so I had to open a position to analyze the data. This is a lot. I don't expect anyone to really be able to understand what's going on here from the start, so we're going to break things down step by step. First thing to know, instructions and compute. Hopefully everyone here knows how to read Etherscan, hopefully, and knows how a transaction on Ethereum works, right? On Ethereum, every transaction is you can send Ether to an address, but you usually call a contract. And once you call that contract, say you call swap on Uniswap router, Uniswap router will then kick off a bunch of other traces to call like different pools and whatnot, or the tokens to do all of your token transfers and whatnot. On Solana, transactions are actually bundles of transactions in a sense. So like who here knows what multi-call is on Ethereum? More or less. So on Ethereum, you can multi-call where you call a contract with an array of basically call data to execute, and that contract will then perform each one individually. Solana transactions do that by default, right? So if I go back to this Explorer here and I collapse it, you'll see that there are 4 instructions. Something about compute, another one about compute, something about increasing position on a perps program, something about closing a position on a perps program. So the very first thing to get straight in your head, yes, you're raising your hand.
Yeah. When you see the metrics, does this show up as a single transaction, or does it show up as 4 transactions?
Good question. So it shows up as a single transaction. So literally when you call the RPC, you get an array. And it's a nested array that's nested like 4 times. Because you have your transaction, you have your instruction, you have your inner instruction. Anyways, we'll go into that. Well, you can kind of see it here. You have your instruction, you have an inner instruction. For example, in this case, when I'm increasing or opening my position on Jupiter, I have to transfer tokens in there. So Jupiter will then go and transfer my 0.069 Sol into my open position. But these instructions are all technically separate, per se, if you're coming from Ethereum land. That can take a while. That took me a while to get used to. And we'll talk about why these instructions are kind of set up this way. Right, so transactions are a bundle of instructions. Each instruction contains the program called, the call data, and then account arguments. All right, so hopefully a program being called and call data being part of the program call is not confusing. Account arguments are probably confusing, right? So if I just open this here, you can see there's params here that go into the call data, and it's calling increase position function. And then you'll see there's a list of 16 different addresses here, right? So why are there 16 addresses here? Well, on Solana, hopefully everyone has seen or heard the memes about Solana being parallelized, and that's why it's fast and cheap and all of that. And the way they do that is they have to know what accounts are being accessed in each transaction, right? So this is the equivalent of if I'm doing a Uniswap swap, I have to tell the Uniswap contract which pools I'm accessing when I'm doing the swap, right? Because essentially, Solana needs to know which accounts I'm writing to, which means I'm changing, which accounts I'm reading from, and also signers, which we're not going to go into signers yet. But I have to put all of these into an array to go into each instruction, right? And that's kind of why these are so long. This would be a lot easier to read without the account arguments, but that's required. This is not optional. If you put the wrong accounts, it won't work. And that's kind of why these are so long. And it takes a while to get used to. Eventually you kind of understand like, oh, this top level has so many accounts because some of those accounts have to be passed into the inner instructions. So it's kind of like the more complicated your instruction, the whole thing is, the more accounts you're going to have up top. I've seen upwards of 30 or 40 account arguments sometimes put into there. Do I love it as a data analyst? Mixed feelings, but it makes sense from a structural perspective, right? Those are your account arguments. Fees, I'm not going to talk that much about fees, but the main thing that you have to understand is you do have gas on Solana. It's called compute. There's compute units that are allocated for each instruction, and you can actually see it. Don't ask me why, but you can see it in the logs, and we'll talk about logs, so you can kind of see down here that there is consumed 3,000 of 128, 1 million compute units. That's kind of your gas, but your fees are not priced by your gas. Right now you could have something that's really expensive compute-wise and still pay the same base fee. That does not scale at all. The fees don't scale, not the chain. So you have you have priority fees, which is you can add a tip on top. Again, the priority fee is just a tip. It is not scaling with the compute at all. This can be confusing because technically, when you're looking at an instruction, you'll actually see there's a set compute unit price and set compute unit limit, and it looks like it's setting a price for the compute, but it's actually not doing that at all. That's just setting a priority fee. Again, very confusing to read, but these are little things. Once you learn it, you kind of learn, oh, this compute unit set limit and set price, that's just priority fee. I don't have to worry about anything else that's going on there. Right? Okay, we're almost through the hard stuff. Well, actually, we're almost through the definitions. Events are messy. My only thing, and I think Austin, John, and others have heard from me for a while, I don't know why Solana decided to do events as just a long array of text. Like if you're on Ethereum and you're used to topic 0 and nice event index logs, you don't have that in logs here. It's to the point where developers will actually create this fake instruction called a self CPI, so you can have a program call itself to emit a log. Again, it's As a data analyst, I've torn my hair out over this. I like self-CPIs. It's probably the best form of events we do have now. If you're doing data analysis back in 2021 or 2022 data, you can DM me for help.
Remember, all the wrong decisions were the right decisions at the time.
Yes. Yeah. Whatever helps you sleep at night. Tokens and accounts. So this is important. So if you've tuned out to now, this is something you do have to pay attention to. On Solana, everything is stored in accounts. So you can initialize an account using system program, which is a native program. It's kind of like a native trace, like the crate trace, for example, on Ethereum. It's not the best analogy, but you have system programs. You create an account, and it's a blank slate, and you can then add kind of programmability into these accounts, right? So I can have a blank account and initialize it with a token mint, which means I'm saying, hey, this account is now a ERC20 like token address, right? And if I want to then hold tokens of that address, I'll create another account and say, hey, this account is only meant for holding tokens of this mint. And you might be wondering, hey, why don't I just do this all in the same account? We're going to talk about that next. But you have to understand that Solana very strictly follows this. You create a blank account, and then you add some programmability or data to it kind of function, right? So the simplest example is for any, like if I take USDC, there's a mint account that I create for it, and then you can have a metadata account, which kind of stores like the symbol, the URI, et cetera, about it. NFTs get really complex. You sometimes have 5 or 6 accounts just for creating a single NFT. And now this does become expensive because accounts have rent. This is something you've probably also seen a lot if you go to a lot of these explorers. This is actually not a good example, but you'll see like account created and then you'll see like 0.002 SOL transferred, right? And that has nothing to do with like what the program is technically doing. That's just, it's creating an account, it's putting rent into it so that Solana doesn't delete the account. This gets really expensive, as you can imagine, if you have like 4 or 5 different accounts, which is also why I think Solana is kind of at the forefront of compression and ZK. I don't think it's because they love compression in ZK. I think it's just because stuff is too costly otherwise. So little tidbits to keep in mind. That's a very quick overview of token and accounts. It's very confusing, but hopefully this next step will make it a little clearer. So Solana programs, actually, you have your native programs like your System1. You have your program accounts, which is like your deployed contracts. We'll talk about that. And then you have your data accounts, which are purely just there to hold data, right? So on Ethereum, when you deploy a contract, you have storage slots. And you can say that your proxy implementation address goes in whatever slot. Your mapping of balances goes in another slot. You don't have slots on Solana. You have accounts, and every account stores a single buffer, right? Think of it as every account is your X variable or your Y variable, and it stores a single string. That's it. There's no slots, there's no mappings, there's none of that, technically, on an account level. So that's why, for example, for tokens, my balance has to be stored in a new account. It's not stored on the token mint, because the token mint is just the program with the code to execute. There's no storage slot. Right, so you can think of this extra account as your storage slot. Again, gets expensive, yada, yada, yada. Deployments, okay. Deployments all go through BPF loader. The only thing that I always point out to people is all programs are upgradable by default, because that's something I think that usually Ethereum people find surprising. Again, has its pros and cons, but it's good for you to know. The storage is handled in a buffer, which again is just a string of data. Because it's just a single buffer, a lot of the times the data structures you work with are just JSON. Like once you deserialize it, 99% of the time it's some JSON object. You can go look at NFT metadata if you want to go see how nested and complex the buffer gets. Or you can go look at drifts position events. Special things to know that can be confusing. Only program accounts get executed. So if I have Uniswap as a factory on, like theoretically, Uniswap factory on Solana, and Uniswap factories create pools, on Ethereum, I can call the pool directly, right? But on Solana, the pool, quote unquote, is just a data account, I can't call that pool directly. I'm always going to call the program, right? Again, this actually makes things easier from a data perspective because all instructions, like every instruction related to Whirlpool or Drift or Jito goes through the same like program, no matter how many like I like to call it factory contracts because I come from the Ethereum world. Like no matter how many factory like child contracts they have, everything just goes through the main program. You can't call the data accounts directly, right? So that's something key to know as well. And so when you call the program account, when you want to then edit like the liquidity in a pool, that program will access that data account through a PDA or a program derived account like signer. Again, I'm not going to go deep into that, but the nice property you get from PDAs in the term of like, in the sense of you have these programs and you have these data accounts separate, is you get account abstraction natively because you can have your token balance sitting there in an account that's then signable technically by, you can program it to be signed by like almost any program, right? So then it becomes a lot easier than trying to like sign someone's balance on a USDC mapping on Ethereum. All right, so that was a lot. How many people are still with me? Okay, all right, not bad, right? So now we did the fun part, right? So I'm looking at this transaction. I did this transfer. There was this amount of base fee that I paid plus a certain amount of priority fee, which like 1,000 microlamp ports, which is not a lot. These are the account arguments that go into my perpetual program call. You can see there's a bunch of stuff in here. For example, like my position has an ATA, which is an associated token account, because when I open a position, there has to be an account that tracks my perp position. There has to be a token account that then holds my tokens from that perp position. And then there's a whole bunch of like other things of like, because I created that position, I now hold this other token that represents my share of the pool. So then there's a new token account created for the position token that I'm holding, right? So there's just like 3 or 4 accounts created in that one step, which is why like, as you can see, as you add more complexity to these protocols, a lot of these accounts are just different token accounts and associated accounts, like 99% of the time. Very few of them are then going to be your like program, like managing accounts or like program logic. So that is to say, most of the time you can ignore half of the stuff you see there. Right, so you have that instruction. I have the transfer to create the perp account position. And then there's a self CPI, which is just a log of the data. So this is just an event that has nice data types like the position key, the side, if it's a long or short, the position size in US dollars, et cetera. That's just an event. And then there's a closed position request, which I'm not really going to get into, but it's basically Jupyter saying, hey, once the position's been opened successfully, close the request for the position. It's not closing the position, it's closing the request. So this really should have been named close request. That confused me a lot when I was first looking into Jupyter data. And then there's another self CPI. And then now because the request has been closed, the request itself also sat in an account, right? Because the request is data. The data has to sit somewhere. So that request sat in an account. Because the request is closed, we don't need that account anymore. We can close it and return the rent to me. So at the very end of everything, the account is closed. This is probably as complex as a Solana transaction gets for most times. Like if you can understand half the stuff I said here, you're well on your way to really understanding a lot of like the inner workings of Solana. A lot of the tricks is just like, as you look at more transactions, you learn the things to ignore, the things to learn, and eventually your life gets easier. Cool, I get the feeling I'm coming up on time. So very quickly, here's a mapping of Ethereum to Solana projects. I have a whole guide that goes really deep into, I saw everyone step forward. Everyone's like, I know this. Like you have all of your equivalents for Maker, for Chainlink, like Chainlink goes to Pyth, Gnosis Safe goes to Squads, Zora, you got Metaplex, Candy Machine, what else on the Yearn, Morpho, all of that. You have Camino, I love Camino. Lido, you have stake pools. I didn't talk much about staking, but staking is probably one of the most interesting things on Solana, and I'm assuming that the Jito team will talk a lot more about it, so I'm not going to talk about it. You actually have ENS on Solana, but that still needs more adoption. And then you have the Telegram bots, of course. But I have a whole article that goes much deeper, so you don't have to try to memorize this. There's an article that is much deeper on like how all these concepts map. So highly recommend you go and read that if you're from Ethereum and trying to better understand Solana. Lastly, tools and resources. So a few technical tools. Program Quick Start, this is one I haven't marketed enough, but you can put in any, this is Dune. You can put in any program ID and see like all of the instructions, the name of the tables, like what account arguments typically go into it. That's a transaction finder. I'm looking at this one, hit capacity. Anyways, you'll have to take my word for it that you can see all of the instructions. You can see like the transaction hash and date that account was created, like the program calls over time, the new and returning users over time. You can also see like the CPI in terms of like, CPI is when a program calls another program. It's what we call a trace on Ethereum. You can see the CPIs of which programs are calling this one and which programs this program is calling. So this is more of like a developer tool, data tool for if you're trying to better understand. Like if you're trying to look for data on a program, this is likely where you want to start from. Other than that, I've written like 5 or 6 different guides on how to understand Solana, mainly from a data analyst perspective. Please go and read those. Those probably answer 90% of the questions you want to ask me. And the last resource I have here is John Wong, who I don't think is here, but I've probably bothered him the most over Telegram. And I believe he's the head of engineering at Solana Foundation, ecosystem engineer. Yeah, smart guy, knows every single standard front to back. I've asked him every question. I don't know if he would like that I send more people to bother him, but he seems to respond. So if you have questions, just reach out to him on Twitter or Telegram. He's a great resource, or bother Austin as well.
Sean's a better resource to bother.
Yeah, that's what you would,
Here, so
that's what you would say. All right, that's it. Thank you. If anyone has questions, let me know.